Good morning. This is Professor Grenfell's Math 12 Statistics class. Probably our last or maybe our second last, I think I said that the past two times, video for the course. All right, so in this video, we're going to go through for Chapter 12, Section 1 on ANOVA. We're going to do exercise, not example. This is from the end of section exercises for 12-1. We're going to do exercise number 17. And here let's describe the problem. It says that we're talking about microwave oven prices. A research organization tested microwave ovens at alpha equals 0.10. Is there a significant difference in the average prices of these types of oven? All right, and then it lists various data right here. It gives us all of the data in raw format. I'll go ahead and include that in the second part of this video because for this exercise, as you can kind of see looking at us right here, we have a computer printout for this. We already have the summary table. So I'll show you this example in a more organized but a little bit chronologically disjoint order. In other words, I'm going to do this back to front, basically. I'm going to do it in two parts, but we're reversing the order of how we should do these parts. Cheating a little bit. Okay, so the data is listed here. We have 1,000-watt microwaves, 900-watt microwaves, and 800-watt microwaves. So those are the three categories that we're comparing. Those are the three groups, or the three populations where we're going to be comparing mu1, mu2, and mu3. The data that are listed are the average prices of these microwave ovens at various different retail models. So we're examining, is there a significant difference between all of these means? So in our hypothesis test, in our ANOVA, remember this is just a hypothesis test. Our null hypothesis is as follows. mu1 equals mu2 equals mu3. So initially we cannot assume anything. We're saying essentially nothing. We're saying these types of ovens, the 1,000-watt, 900-watt, and 800-watt ovens, doesn't make a difference in the price. The average price is the same for all of them, right? It's not a factor, in other words. And then the alternative hypothesis is going to be there's at least one that's different, right? There's a significant difference between at least one or two, or maybe they're all different, but this is just going to detect one distinction. So we're simply negating the null hypothesis by saying at least one is different. Right, so there we are, H subscript 1, at least one mean is different. Now, in step 2, we're going to go ahead and sketch the distribution, and I've done that right below here. Okay, so here is the general shape of the F distribution curve. Remember, it doesn't have to be perfect. And then I've gone ahead and shaded in the critical region. So it's starting right here. And that has an area underneath the tail of 0.10, right? And now we have to go to table H in the book. That is the table of critical values for the F distribution. We have to utilize the degrees of freedom for the numerator and the denominator and the value of alpha in order to look up this critical value right here. And so we'll do that now. And here, I forgot to say, but based on the data that we have 3 groups, so k is equal to 3, and that's how we got the degrees of freedom for the numerator, that is k minus 1. And then similarly, we had a grand total of 20 pieces of data. 22 pieces of data. And so that means we did 22 for capital N minus 3 in place of k. That gave us the degrees of freedom for the denominator, 19. So using those two values, together with alpha equals 0.10, that indicates for us, that's what tells us that we are on page 787 of table H, not in a different page, because that is the one corresponding to alpha equals 0.10. And looking in row 19 and column 2, right, for the correct degrees of freedom for the denominator and the numerator, we look up the critical value of 2.61. So that defines our critical region, and so that's what we want to do in step 2. And usually we use that in step 3 and step 4 as well. So I wanted to write that underneath our summary table. Now let's go into the computation. So the nice thing here is that we have already got somebody, namely the computer, to do all of the computations for us. So remember, this is what we would do. We would do our calculations for the grand mean. We would have to get all of the means for all of our samples. So notice here in the descriptive statistics, they've gone ahead and done that for each of these groups, right? Here we have the 1,000-watt microwave groups and 900 and 800 and so on. They've already calculated all of their means and variances. Well, they've given it to us in the form of standard deviations. But then, in addition to that, they've also calculated the sums of squares, and then you can fill in the rest of the table based on essentially the information that we have. So notice here, we are putting in k minus 1 for the degrees of freedom for the between group variance. That would be capital N minus k, so 22 minus 3 gives us 19 for the degrees of freedom here. And in order to get the mean square, all we're going to do is take this value in this column divided by the value in the previous column. So with your calculator, for instance, you can notice, you can easily verify that 21,729.735, wow, that was a mouthful, divided by 2 is equal to 10,864.867. So that is how we would fill in these values here. We would just take here, again, we'll take 20,402 divided by 19, and that works out as 1,073, etc. All right, then the next thing we would do after that is we compute the test statistic. And so here it is simply a matter of dividing this one in the top here by this one in the bottom. And that's how we get that. The p-value, let's for the time being, this part over here, we don't necessarily always include this. So just for the moment, we'll pretend we don't know what it is. Hopefully I can erase that and have it still show up. At any rate, we're using the traditional method, and so we're going to take our F statistic and just see where it is on our distribution curve. Remember, all of these values along the horizontal axis are all F values. And so where is ours on this scale? Well, maybe it's not to scale, but we're past the critical cutoff value. Our F score is 10.118, and the critical value was 2.61. So we are well into the rejection region. Therefore, our decision for this hypothesis test is going to be to reject the null hypothesis And so therefore, to summarize the results, it's actually really quite simple. So to summarize this, to summarize the result of any ANOVA experiment, I just quickly referenced what I had written in the alternative hypothesis. So we reject H subscript 0, okay, throw it away. So what is left? It has to be H subscript 1. So we say we found evidence. Let's see, the evidence, always mention that, suggests that at least one of the means is different. So notice we just parroted exactly what we had written for H subscript 1. And that concludes the ANOVA test. That is using the summary table. Okay, and so as I had mentioned, we are essentially kind of cheating and doing this problem in 2 parts, and assuming that we had done part 1 before we actually did part 2. And so here's actually part 1. So here are all the data. Notice we have it all separated into columns for 1,000-watt microwaves, 900-watt microwaves, 800-watt microwaves. So there, we'll separate it like that. All of these ones, notice when we count up all of these values, we get capital N is equal to 22. So you can verify that. K is equal to 3. That's the number of different groups of items that we're comparing. And now, like I mentioned, we're just going to quickly do the calculations for this. So I'll let Google Sheets do this for us. So here we are. I have overlaid the completed calculations. All of these in this row are chi-bar. And here we actually have the standard deviation instead of the variance. So remember that it's S instead of S squared. So therefore, in the formulas where we see S squared, we'll have to remember to square these values. And here also, we're able to quickly go back and just reference the descriptive statistics that we had in the summary and see, okay, look, the mean and the standard deviation is the same as what we got here. And you can verify that for all of those. And so here is the calculation for the sum of squares between groups. And this whole thing works out as I'm getting 21,725.84 because I rounded these to 1 decimal point. And oh, the thing that I forgot to mention here is, I didn't show this calculation, but chi-bar subscript GM, that is the grand mean, the mean of, well, all of these data values from all 1, 2, 3 samples. We've got 22 values total. So we sum them all up. That's the sum of all X, I believe here, well, what's that, 4,270. And then we divided that by the total number. So capital N, that was 22. And that's how I got this 194.1 business that I am, that you are seeing here in this, in this equation, in this calculation. And then similarly for SSW, the sum of squares within, here the formula is N subscript I minus 1 times S subscript I squared, okay? So here we actually have the S values, not the S squared values. So here we are taking, 28.2, squaring it, and multiplying that by, for the first group, the sample was 6, so 6 minus 1, and so on and so forth. And what we get out here is 20,402.08. And here we had this. And if you flip back and compare, you'll notice they're not identically the same. But why is that? That is just due to rounding error. And then from there, the rest of the values, we discussed how you would fill them in. So essentially, this is all we need. We need the degrees of freedom and then the sum of squares. Everything else from the chart we can fill in from here. So it's just these first two columns, the degrees of freedom and the sum of squares, that become crucial in analyzing and summarizing, or utilizing, I should say, using an ANOVA summary table or source table. All right, we'll end this lecture here and perhaps just do one more simple, quick example afterward. Okay, bye-bye for now.